Light. Lesson preview. Reflection of light. Regular and diffused reflection. Laws of reflection. Image formed by a plane mirror. Multiple reflections. Uses of plane mirrors. Dispersion of light. Rainbow. Refraction. The human eye. Persistence of vision. Defects of vision. Eye care. Visual impairment. Some animal facts. We cannot see objects in the dark. Light enables us to see things. We are indeed very lucky to be blessed with the sense of sight. We are able to see so many wonderful things around us. In this chapter, we shall study about reflection of light and how we see with our eyes. Reflection of light. We have already seen in the previous class that when light rays fall on a highly polished surface, they bounce back. This is called reflection of light. Luminous objects such as the sun or a CFL give out their own light. Non-luminous objects like a chair or a notebook do not give out their own light. We can see an object only when light from the object reaches our eyes. How can we then see non-luminous objects? It is so because when light falls on a non-luminous object, part of it bounces back from the object. When this light reaches our eyes, we are able to see the object. This bouncing back of light by objects is called reflection of light. The amount of light reflected depends on the material and nature of the surface on which the light falls. An opaque object absorbs some of the light that falls on it and reflects the remaining light. A transparent object allows almost all the light to pass through it and reflects very little light. A smooth and highly polished surface, i.e. a shiny stainless steel surface or a mirror, will reflect almost all the light falling on it. Regular and diffused reflection. When a ray of light falls on a smooth surface like that of a mirror, the light is reflected along a particular direction. Reflection of light from a smooth surface is called regular reflection. The image formed is clear and sharp in this case. When parallel rays of light fall on a rough, irregular surface, the reflected rays are not parallel, but are reflected in different directions. The image formed is not clear and sharp. This is called irregular or diffused reflection. Reflection of light from old stainless steel utensils, paper, and wall are examples of diffused or irregular reflection. Regular and diffused reflection. Regular reflection, diffused reflection. Activity. Take a white sheet of photocopier paper and fix it on a drawing board. Take a comb and close all its opening except in the center with the help of a black chart paper. Hold the comb perpendicular to the sheet of paper. With the help of a torch, throw light through the slit of the comb from one side. With a little bit of adjustment of the torch and comb, a ray of light along the paper on the other side of the comb can be seen. Now place a mirror in the path of the light ray. What do you now observe? After the light ray falls on the mirror, it is reflected in another direction. Arrangement for showing reflection. The ray of light which falls on the reflecting surface is called the incident ray. The ray of light which bounces back or is reflected from the surface of an object is called the reflected ray. Draw lines showing the position of the mirror, incident ray, and reflected ray. Remove the mirror and then draw a line perpendicular to the mirror at the point where the incident ray strikes. This is known as the normal. The angle between the normal and the incidence ray is called the angle of incidence, I. The angle between the normal and the reflected ray is called the angle of reflection, R. Measure the angle of incidence and the angle of reflection. Repeat the activity by changing the angle of incidence. What happens to the angle of reflection? Does it also change? Is there any relationship between the two? You will notice that the angle of incidence is always equal to the angle of reflection. Angle of incidence and angle of reflection. Reflected ray, incident ray. Activity. To show that the incident ray The reflected ray and the normal at the point of incidence all lie in the same plane. Take a wide sheet of stiff paper like art paper. Fix it on a drawing board in such a way that it projects slightly beyond the edges of the drawing board. Place a plain mirror strip on the paper holding it vertically with a mirror stand. Throw a ray of light on the mirror in the similar fashion as in Activity 1 or use a sheet paper with a hole in it. Look at the reflected ray. You will notice that it extends to the projected portion of the paper. Bend the part of the projected portion on which the reflected ray falls. Do you still see the reflected light on the bent portion of the paper? Now, bring the paper back to the original shape. Can you see the reflected ray again? Yes. The reflected light is again seen on the paper. Incident ray, normal, reflected ray, mirror. The entire sheet of paper spread on the table represents one plane. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the plane of the paper. When the paper is bent, a plane different from the plane in which the incident ray, reflected ray, and normal lie is created. The reflected ray of light does not lie in the new plane formed due to the bent sheet. Can you tell what this indicates? This suggests that the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Laws of reflection. The two laws of reflection are: the angle of incidence is always equal to the angle of reflection. I equals R, A on equals BON. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. Images formed by a plane mirror. You have already learnt about some of the features of the image of an object formed by a plane mirror. Let us revise some of them. A plane mirror forms an erect image. The sizes of the image and the object are the same. The distance of the image from the mirror equals the distance of the object from the mirror. The image formed is virtual, i.e., it cannot be obtained on a screen. The image shows lateral inversion, meaning that the left of the object appears on the right and the right of the object appears on the left. Ray diagram for the formation of image by a plane mirror. A ray of light falling on a plane mirror gets reflected in such a manner that the angle of incidence is equal to the angle of reflection. A ray of light falling on a plane mirror at 90 degrees gets reflected back from the mirror along the same path. Reflection of rays from a plane mirror, 90 degrees. Reflected ray, incident ray, reflected ray. N, normal, incident ray. Activity. List the diagram. Two rays O and OB are incident on the mirror from the source of light O placed in front of the plane mirror. The reflected rays are AC and BD respectively. Extend these two reflected rays backwards. You will notice that they will appear to meet at a point. Call it I. Point I is the image of the object O. The reflected rays do not actually come from I, but only appear so. We thus say that the virtual image of the object O is formed at I. Multiple reflections. What will happen if we use two mirrors? What kind of images will we get? By varying the angle between the two mirrors, a number of images will be obtained. This so happens because the image in one mirror acts as an object for the other mirror. When the two mirrors are placed at right angles to each other, three images are formed. As the angle between the two mirrors is decreased, the number of images are increased. When the mirrors are placed parallel to each other, we get an infinite number of images. The number of images formed by mirrors at an angle is given by a simple formula. If is the angle of inclination between two plane mirrors, then the number of images, n, formed is given by the formula, n equals 360 degrees /-1. Table S. No. Angle between the mirrors. No. Of images. N. 1. 90 degrees. 3. 2. 60 degrees. 5. 3. 30 degrees. 11. 4. 0 degrees. Infinite. Now you will be able to understand why the hairdresser holds a mirror behind you while you sit in front of a mirror to show you how your hair has been cut. Can you name the device which you studied about in your previous class made by using two plain mirrors? It is used in submarines, tanks, and by soldiers in bunkers to see things outside. Let us make a kaleidoscope. It is based on the principle that a number of images are formed by mirrors placed at an angle to one another, i.e. on the principle of multiple reflection. Activity. Take 3 rectangular mirror strips about 15 cm times 4 cm in size. Join them to form a prism. A. Make a tube slightly longer than the glass. Strips from a thick chart paper. B. Fix the prism inside the tube. Cut a circular disc. Make a hole in the center through which you can see and cover one end of the tube with it. At the other end, touching the mirror, fix a circular plain glass plate. Put several pieces of broken glass bangles on this glass plate. Close this end of the tube with a ground glass plate. There should be sufficient space for the glass pieces to move. When you look through the hole, you will be able to see a variety of patterns. Do the patterns repeat? You will never see the same pattern again. Whole pieces of colored glass. Uses of plain mirrors. We commonly use plain mirrors at home to see our reflections. In salons and beauty parlors, plain mirrors are kept at various angles to view sides of head and face. Parallel mirrors are kept to see back of the head. Plain mirrors are used to reflect light on objects. For instance, during outdoor film shooting, metal sheets are used as plain mirrors to reflect sunlight on actors. Plain mirrors are used in solar cookers to reflect sunlight on food being cooked. Plain mirrors are used in periscopes. A submarine crew underwater can see objects, enemy ships, on sea surface, using the periscope. Dispersion of light. When a ray of sunlight passes through a glass prism, it splits up into a band of colors: red, orange, yellow, green, blue, indigo, and violet. The process of splitting up of white light into many colors is called dispersion of light. The band of colors produced when white light is split up is called a spectrum. The dispersion of light into 7 colors occurs because light rays of different colors bend differently while passing through a glass prism. Red light travels the fastest and bends the least, whereas violet light travels the slowest and bends the most. Dispersion of light: white light, red, orange, yellow, green, blue, indigo, violet. Activity. Take a bowl of water, place a small plain mirror in the bowl, and set it at an angle of about 45 degrees on the wall of the bowl. Place the bowl near a window so that the mirror may face the sun. Adjust the position of the bowl so that mirror may reflect the sunlight on a wall. In case the wall is not white, fix a sheet of white paper. What do you observe? You will see a wonderful spectrum on the wall as the mirror and water form a prism. Rainbow. Rainbow is an example of dispersion of light. The drops of water, which remain in the air just after the rain, act as small prisms. They split sunlight which falls on them into the 7 colors. The dispersed light from a large number of drops appears as the rainbow. Rainbow. Refraction. Refraction of light is the change in its direction or bending of a ray of light as it passes from one medium to another. It can be seen easily in transparent mediums such as air and water. When a ray of light travels through air and then passes into water, it tends to change its direction and bends towards the normal. Reverse of this happens when a ray of light travels from water or a prism into air. It tends to deviate from the ray of light, normal line, air boundary, water, normal, or disperses. This is why white light disperses into different colors when it passes from the prism to air, boundary, water, ray of light, normal line, ray of light again refracted, air. The human eye. Eye is the most important sense organ. It is very delicate. The main parts of the eye are as follows. Cornea. Cornea is a very thin transparent membrane which covers the front of the eye. Iris and pupil. Behind the cornea is a dark-colored muscular structure called iris. The central circular opening in the iris is called the pupil. The pupil appears black in color because no light is reflected from it. The size of the pupil is controlled by the iris. The iris increases and decreases the size of the pupil to regulate the amount of light that enters the pupil. The iris gives the distinctive color to the eye. Eye lens. Behind the pupil is the eye lens. It is a convex lens made up of a transparent jelly-like material. Retina. In the back of the eyeball is a lining called the retina. The eye lens focuses the image of the object on the retina. Retina contains several nerve cells. It has two types of sensory cells called rods and cones. The rod-shaped cells are sensitive to dim light. The cone-shaped cells are sensitive to bright light and can detect colors. The image formed at the retina is smaller than the object and inverted. It is sensed by the nerve cells and then sent to the brain through the optic nerve. The brain interprets the correct image which we finally see. Blind spot. There are no rods and cones at the junction of the optic nerves and the retina, so no vision is possible in this region. This is called the blind spot. Activity. To demonstrate the presence of blind spot in a human eye, take a sheet of white paper and mark a circle and a plus sign on the two sides of the paper. Close your left eye and hold the paper in your hand looking at the circle continuously. Move the paper towards yourself. You will notice that at a point, the plus sign will disappear. Next, close your right eye. Look at the plus sign and again repeat the activity. This time the black circle mark will disappear. This activity shows that there is a point on the retina, blind spot, which is unable to send a message to the brain when light falls on it and hence the image is not seen. Persistence of vision. The image formed on the retina does not disappear immediately. It persists for 1/16th of a second after we stop looking at the object. This phenomenon is called persistence of vision. This is used in moving images that we see on TV or cinema. A number of images are flashed before our eyes in succession at a rate more than 16 images per second, and it appears like a movie. Activity. Cut a square piece from a cardboard 8 cm by 8 cm, make 2 holes in it opposite to each other, and secure a loop of string through each hole. Draw a fish on one side of the square and a glass bowl on the other side. The 2 pictures drawn should be centered on the square piece. Hold the string ends, one in each hand, and twist the strings to make the square piece twirl rapidly. What do you see? You will see the picture of the fish in the bowl. We see a moving picture because the 2 pictures are made to move at a very fast rate, faster than 1/16th of a second. Persistence of vision. Reverse side. Front side. Defects of vision. Short-sightedness. Some people can see nearby objects very well but cannot see distant objects clearly. They are said to be suffering from short-sightedness or myopia. Long-sightedness. Some people can see distant objects very well but not close objects. They are said to be suffering from long-sightedness or hypermetropia. Cataract. In old age, the eyesight usually becomes foggy. This is because the lens becomes cloudy, leading to loss of vision. This is called cataract. Cataract can be treated by removing the opaque lens through a minor surgery and inserting a new artificial lens in its place. Color blindness. Color blindness is usually a genetic, hereditary disorder that affects a person's ability to see or recognize certain colors. Sometimes color blindness may be due to physical or chemical damage to the eye, damage to the optic nerve, damage to parts of the brain that process color information, cataract or age. Most colorblind people lead normal lives. Eye care. Since eyes are delicate and extremely valuable, it is necessary to take proper care of them. Have a regular eye checkup from an eye specialist. Use spectacles if advised. Protect eyes from the glare of the sun and also from dust. Do not look at the sun or a source of powerful light directly. It can injure the retina. Wash your eyes frequently by splashing clean and cold water whenever your eyes feel strained. Do not rub your eyes. Do not watch television for long hours. Do not read in dim light or in moving vehicle or while lying down. This causes strain on your eyes. Always read at the normal distance for vision, 25 centimeters to 30 centimeters. Do not read by keeping the book too close or too far from your eyes. Have a diet rich in vitamin A. Deficiency of vitamin A causes night blindness. The person suffering from night blindness cannot see properly in dim light or at night. Foods rich in vitamin A are vegetables such as raw carrot, broccoli, spinach, milk and milk products like curd, cheese, butter, eggs, fruits such as mangoes and papayas, cod liver oil. Visual impairment. Visually challenged people cannot see. Such people try to identify things by feeling and listening to sounds carefully. A special system called Braille is used by these people for reading and writing. The Braille system was invented by Louis Braille, who himself was a visually challenged person. This system was adopted in 1854. The Braille system uses a pattern of raised dots to represent letters and numerals. Each Braille cell consists of 6 dots, arranged in a rectangle of 2 columns of 3 dots. Braille system has 63 dot patterns or characters. We can read many Indian languages using the Braille system. Louis Braille. Some examples of dot patterns used in Braille. A visually challenged person recognizes each letter by the position of dots in each cell. Braille printing is done in special printing presses. These days computers are used in these presses. Nowadays, special keyboards based on the Braille system, with embossed characters, are available. Special scanners and printers are also available. Devices like talking calculators, audio dictionary, dictaphone, audio measuring devices, etc. are very useful to the visually challenged. Some animal facts. Daybirds like eagles and kites have more cones and fewer rods compared to night birds like owls, which have a large number of rods and only a few cones. Hence, an owl has a large pupil. It can see well during the night and not in the day. Crabs can look all around. Rabbits and parrots can look behind them without turning their head. Owls are the only birds which can see blue color. Butterflies have compound eyes, having many lenses. They can see in different directions at the same time. Crocodiles are blind in water but can see on land. Chameleons can look in different directions at the same time.